morning everybody. So I'll welcome all the viewers for this video lecture series of the subject Signals and Systems. So you can see the name of the subject code is 201181. This is one of the prominent subject of second year engineering of Pune University, and especially for electronics and telecommunication branch. As of every one of you might be knowing that the subject is of 100 marks, and at the end of the semester we have an oral exam for the subject which is comprising of 50 marks. So altogether the weight of the subject is around 150 marks. Now this forms one of the very core subjects of electronics engineering because it involves all the concepts of electronics plus telecommunication engineering, wherein we deal with signals and how to process these signals. So if you see these subjects, namely signals and systems, digital signal processing, digital communication, advanced digital signal processing and image processing, these all subjects are in one queue. And for all these subjects, signals and systems forms the core of the basic subject. Okay. Now, as of every subject, this subject comprises of 6 units. So I'll be discussing about all these units in due course of time. So today what I'll be doing is I'll be providing you an overview of Unit 1, and as Unit 1 comprises of around 4 chapters, so we'll try to cover one chapter in brief. Before I start with the subject, let me tell you some of the books which will be helpful for you for your subject. Now this is the first book, Signals and Systems by Simon Higgins. This is by John Gilley publication. This is one of the Bible books for signals and systems. I mostly recommend these books to our students, and almost 3 to 4 units of our syllabus are being set from this book. So you can always refer this book, and most of the unsolved questions of these books we'll try to solve it in our series, video series, and mostly the question paper is also been set from this book. Other book which I would recommend for this is Signals and Systems by M.J. Robert. This is given by Tata McGraw-Hill, but I think for a normal student it will be a little difficult to digest. So as an alternative to this, I would suggest one more book, which is this one, Signals and Systems by P. Zhu. So this is Shom series publications by again McGraw-Hill, and basically what is the importance of this book is that there are so many solved numericals in this book which are being widely required by students of second year engineering to understand few concepts, and which you can actually practice it and which will be helpful for them in the exams. So 2 books will be very sufficient for the student. First is, as I told you, Signals and Systems by Simon Higgins, and the second book is Signals and Systems by P. Zhu. Now this Shom series publication, this is very famous, and this is not only for signals and systems, this you'll find even for other subjects, namely SSDC or even DS or even control systems. So for so many mathematical subjects, Shom series is a title which has been for, not for electronics engineering, even for other branches of engineering. So this is dedicated for solving numericals for a particular subject. So as I was telling you that today we shall be getting an overview of Unit 1 and try to complete one of the chapters of Unit 1. If you could see, the name of the first unit is Introduction to Signals and Systems, and it basically comprises of 4 units. So that will be the contents of Unit 1. So what are the 4 chapters? Classification of signals, basic signals, operations on signals, and systems. So today I shall try to cover this chapter and give an overview of another chapters also. So you can see these are the 4 chapters, and let me discuss each of these chapters in detail. So why classification of signal is at most important? Because we want to know what are the characteristics of the signal. Many times the behavior of the signal depends upon the characteristics of the signal. So we are classifying different signals now based on the characteristics of the signals. So we want to know that which signal fits into which category. So that is the main motto of classifying the signals. So we are classifying different signals under different heads, namely continuous and discrete time signals, periodic and non-periodic signals, deterministic and non-deterministic, so which is also known as random signals, then energy and power signals, and even and odd signals. Now there can be different or there can be innumerable classifications of signals, but at a primary level in second year engineering we can classify some signals under these headings. Let me tell you again, there can be innumerable number of classification heads, but these are the primary or basic levels over which we can classify the signals. So let us take the first one, continuous and discrete time signals. So as I told you, we will be discussing with different chapters in unit 1. So first chapter is classification of signals. Before we classify the signals, we should know what actually a signal is. So today we are going to see, or say now we are going to see, definition of signal. How is a signal defined? I'll write down the definition. Signal is formally defined as a physical quantity that varies with time, space, or any other dependent or independent variables, and which conveys information based on the nature of physical phenomena. Now, in this whole definition of signal, two words are very important. What are these two words? Namely, varies with and conveys information. Now, what is the importance of varies with? Something which varies, it conveys information. Like, for example, if you could see, what is this? Everyone can clearly say that this is a DC signal of some amplitude A. Actually, if you could see a DC signal and if you could try to hear it into a loudspeaker, if you see this, if you try to hear this signal, then it's a very annoying noise, namely chung. Now it doesn't convey any information because it is, it is fixed. It is not varying with time. Now to the same signal, if I put it in this way, say something like this, wherein it has different amplitude, certainly it is conveying some information. Now whatever even I am saying, it will be having a nature something like this. But something which varies always conveys information. Something which is fixed, stagnant, doesn't convey information. So what we are trying to say in this particular signal, or the definition of signal, is that it varies. The signal varies with time, space, or any other dependent or independent variables. So whenever it is going to vary, it is going to convey information. Just like I told you in this signal, since it is not varying, the first one, it is not conveying any information. And in the second case, wherein it was varying, it is conveying information. Now it is varying with time, so it is conveying information.